didn't study.
Okay. Finally getting on to solving equations.
Yay!
Finding some answers for this x, or a, or b, or whatever the variable is. Finding what the number will be. So we want to translate this into another way of writing it. X's and A's and B's are just, you can just have an empty box if you want. Which translates to what number minus 7 gives 12?
What?
19?
Yeah.
Happy with that?
19, yeah. 19.
19 minus 7 equals 12. So 19, x must be 19. Okay, we can do this for all of these. What's this one? Is that, what operation is this? Yeah, so we can rewrite this as some number divided by 7 is equal to 2. So this is division. Now, what's this one then?
Multiplication.
Multiplication. That's some number, or 6 times some number is 24. So you probably start to figure out what the sum number is for most of these without having any sort of method or anything like that. I want to use a method because if I use a method now, then when they get much more difficult, which they will very fast, that we are able to solve them without just knowing what the answer is. So for instance, if I have something like this, I don't just know what the answer is anymore. That's some number minus 7 times the number plus 3 is equal to 24 times the number minus 3. It's not as easy as just some number minus 7 is 12. So I want to get a method that I can use for this one, but I learned it on the slightly easier ones. Now the method I use is a balance approach. I do the opposite, and then I balance the equation. This is really just a two-step approach. I do the opposite. What do I do the opposite to get rid of a number? Rid is not very mathematical, but you might remember it. And then to balance, I do it to both sides. Both sides of what? Of the equal sign. So there's two sides to this equation. I look at this first one. I got like the the left-hand side and the right-hand side, and it's kind of like the equal sign is a balance point. So I want to make sure that if I do something to an equation that I do the same thing to both sides to keep it balanced. Otherwise, I change the equation. Okay. So my method is do the opposite. I don't want this minus 7 here. I want the answer x equals. So my opposite thing to do, instead of subtracting 7, I'm going to add 7 to both sides of the equation. I'm going to add 7 here and add 7 here underneath to the left and the right. Notice this is the left-hand side over here and this is the right. I draw a line underneath, and then well, there's nothing to add to the x, so I just have x left over. But minus 7 plus 7 disappears. It's 0, isn't it? If I add and subtract the same number, the equal sign is still here, and I get 12 plus 7 is 19. Okay? So what did I do? I did the opposite operation to both sides, and all of a sudden, the 7 is no longer with the x, it's with the 12 over the other side. And that's my answer. I have an x equals. Now I know what you're thinking. This is a very complicated way of doing something very simple, but it will help you, I guarantee you. So I want you to try and use this method. I know that you can do a lot of these in your head, but try and use this method. So it'd be a good idea to either put in your notes now or later these methods. This second one, I have a 4 here. If there's no sign in front of the 4, what is it? Is it positive or negative? Yeah, it's automatically positive. It's like when you count numbers, you don't say +4, you just say 4. But yeah, this is automatically positive. So if I want to get rid of this 4, what do I need to do? To get rid of it, I do the opposite. The opposite to adding 4 is subtracting 4. And I subtract it from both sides that equals. So notice I write it on this side. I don't write it under the x, because I want to subtract it from this. So I subtract 4 from both sides. Now when you get quicker at these, you might need to write this step, but we're trying to just learn the process slowly. 4 take away 4 disappears. That's exactly what I want. It says both sides of equals to get rid of that number. Zoe's squinting at my term. X is left behind here. Plus x is just x. And I have 6 minus 4 is 2. And here's my answer for x. The next one we figured out was division. This is x divided by 7 is equal to 2. So how do I get rid of this 7? I always think do the opposite. Do the opposite. I multiply by 7, yeah, times by 7. Where do I multiply by 7? Both sides of, make sure I balance it. If I only multiply one side by 7, I unbalance it. I make it 7 times too big. So I multiply this side by 7 and this side by 7. The right-hand side here is pretty easy. 2 times 7 is 14. The left-hand side, what happens? If I multiply, no, this is dividing, remember? If I multiply by 7 and then divide by 7, what's actually happening? Nothing's happening. So they are opposite operations and they cancel each other out. Or 7 over 7 as a fraction is 1. So that's just 1x, which is exactly what I wanted. So 1x is 14. Which you could have figured out here at the start. 14 divided by 7 is 2. Last one. We know it's 6 times a number is 24, so what's the opposite? Always the method is do the opposite operation to get rid of the number. So I want to get rid of this 6. So at the moment it's 6x equal to 24. I can divide both sides by 6. Remember, do the opposite. So the opposite to multiplying by 6 is dividing by 6, and then balance it. Do it to the both sides of the equals. So if I divide both sides by 6, on the right hand side 24 divided by 6 is 4. On the left hand side 6 divided by 6 is 1. So that's 1x, which is what I want. X. Okay. Maybe a bit obvious, but I would like you to